And it's perfect because this is a type 1a supernova, which are quite rare.
That's right. We use these to measure how the universe is expanding. So they're bright, so you can see them from a long distance away. And that means we can use them to work out how the universe is accelerating. But embarrassingly, we don't know what they are. We've got some ideas that there might be a massive star spiraling material down onto a white dwarf, which then explodes. But we're not sure. And that's why we need these local ones to try and help us.
Because this is only sort of 12 million light years away, which is pretty local.
It's just around the corner.
Yes. Is it still visible now, or does it decay very rapidly?
Well, it'll be visible for the next few months, and actually it was caught early enough that it was still brightening, and so it'll be at its brightest about now. So you could go out, find M82, and if you look in binoculars, you should see it easily. Won't quite make it to naked eye visibility unless something odd happens, but it'll be an easy target in binoculars, and the brightest supernova we've had in the northern hemisphere for years. Now, speaking of celestial spectaculars, we had hoped before Christmas that Comet ISON was going to put on a great show for us, but it didn't quite work out like that, and Alan Fitzsimmons is going to tell us why.
People were predicting that ISON would be the comet of the century. That as it came round the sun, a huge tail would be created that would fill the night sky. However, instead, it seems to have fizzled out. But now, by pooling data from a number of scientific instruments, it's possible to find out what actually happened.
Here we've got the comet about a couple of hours before closest approach to the sun. And we can already see that something has happened to the comet, because in a normal comet we expect to see a very bright, distinct head or coma formed from all the gas and small dust particles that the comet has released. Here we can see the tail of the comet, but the head itself is already not looking like a normal comet does. It's spread out, and we believe that even by this point, a couple of hours before it reached its closest point to the sun, the comet nucleus itself had been dispersed. Now, interestingly, it's still far enough from the sun that it shouldn't have been broken up by the gravitational field, the tidal forces imparted on the nucleus by the sun. But what's happened is simply the nucleus has been heated so much and it's releasing so much gas and material from its surface that that pressure of that material building up in the comet has simply broken it apart.
And so ISON was doomed long before it reached the sun, and as it passed around our star, it reappeared as nothing more than a cloud of debris. But there was still a question about whether anything of the nucleus had survived to live another day.
On December the 16th, the Hubble Space Telescope went to have a look at where the comet was predicted to be. Now, it's tracking where we expect the comet to be moving, so all the background stars and galaxies appear as streaks. But if there was any comet left, we would see it as a point-like source here. We don't see anything. So these Hubble telescope images here imply that there really isn't anything left at all of the nucleus. So it's a shame. ISON is gone, but it gave us a great show on its way in.
And we've got one more item of news this month.
In January, as part of Stargazing Live, I challenged people to go online and look at pictures of galaxies and look for gravitational lenses, places where a distant galaxy has had its light bent by a gravitational lens by passing near a nearby galaxy. And we found lots of spectacular things, but the one we talked about on the night was this one. This is an infrared image of that galaxy.
Yes. So what have we got? In the centre, that's the galaxy.
That's the nearby galaxy.
Lovely.
And then the red arc that you can see, almost the red ring, there is a distant galaxy whose light has been bent, and we're seeing it because it's being lensed by this nearby galaxy.
So without that galaxy, we wouldn't have a chance of seeing it.
Right, exactly. It's nature's telescope, but this is the infrared. What we've been doing since is we've looked at it in the radio using Jodrell, and this is the image that we've got.
But it does look quite different.
It does. For starters, it's blobby because it's a radio image and you don't quite get the beautiful pictures you do in the infrared. But the other thing, I don't know if I can convince you of this, but in the infrared we saw that red ring. In the radio, it's only one arc, one side.
Actually, yes, it does definitely look one-sided. So where's the rest of it gone?
Well, exactly. It's quite confusing. And our best guess at the minute is that the radio and the infrared radiation come from different parts of the galaxy. So the infrared comes from star formation, spread out through the whole galaxy, and the galaxy's forming stars at a great rate, about 100 times that of the Milky Way. And the radio, we think, comes from right in the centre, from the nucleus, where material's spiralling onto what must be a growing black hole in the centre of this galaxy.
This is what I love. Looking at the sky in different bands of the electromagnetic spectrum gives you very different viewpoints and different understandings.
That's right, and we knew that was true, but I think it's only the second time that we've seen this misalignment between a radio lens and an infrared lens. So perfect ring in the infrared and a nice blobby arc in the radio. It's quite fun. If you go to the Sky at Night website, we've actually put some more data online. If you follow the link, you might be able to discover your own lensed galaxy. Well, back to Jupiter, and we're in the Endeavour room of the Royal Observatory Greenwich, which these days is a library, but which used to house some of the largest telescopes on the site. It was in this room in 1908 that British astronomer Philippe Melotte discovered a moon of Jupiter. And this is the image, and this dot here is the moon we now call Pasiphae. And exciting things are happening with the moons of Jupiter, and to discuss them, I'm joined by Dr. Lee Fletcher, an expert on the Jupiter system. Lee, welcome to the programme.
Thank you.
We're going to talk about Europa, where jets of water have been discovered shooting into space, but we knew there was water on Europa already.
We did. I mean, Europa has always been a tantalising place for us to one day go and explore. And now, more so with this new result of plumes of water vapour being emitted from the south pole of Europa, it's going to be a fabulous thing for us to go and look at one day.
So Europa's an icy moon, and that's what we see when we look at the surface.
Yeah, Europa is the second of 4 Galilean satellites in orbit around Jupiter. It's about the size of our own moon. And if you look at it here on the screen, you can see that it's an icy ball, Europa is. And the different colours that you see across the surface are contaminants in the ice itself. And it almost looks like you've got frozen ice rafts frozen then into a body of liquid water that is refrozen. So we call it chaos terrain.
We can zoom in, I think, and get a proper look. Yeah, there we go.
And this is one of the key pieces of evidence which suggests that beneath this terrain there's liquid water in our solar system, locked away beneath the icy surface.
But we've been talking about this for years, and there's this annoying catch, isn't there, that the ice is actually pretty thick.
This is the typical thing within our solar system of the ability to sense what we really want to see, which is that ocean, is forbidden to us, because it's hidden away, locked away. Or so we thought. But now, with the discovery of these water vapour plumes, we have a tantalising chance to fly through those plumes and sniff out the composition.
Well, let's look at that new observation. So this was released at the end of last year. It's a Hubble Space Telescope observation. And I have to say, Lee, look at this, it's not hugely convincing.
Well, I'm very sorry that you're disappointed, but this is actually a really exciting discovery that the folks with the Hubble Space Telescope made just a little while ago. Now, don't forget that you're seeing this from planet Earth, 5 astronomical units away.
5 times as far away from the Sun as the Earth is.
Absolutely, all the way out of the orbit of Jupiter. This is an artist's impression superimposing the two things together. What they're looking at here is ultraviolet emission from hydrogen and oxygen. So this is water that's been spewed out of the moon and has then been dissociated, split apart.
Just by the sun's light.
Exactly, by UV radiation. And we can see that emanating from the South Pole. So we're talking about a plume of water 200 kilometres high over the South Pole of Europa. And I can tell you we didn't expect to see that.
So how have we got water at the South Pole?
Well, what's going on here is we've got these cracks and these fissures and stripes which are undergoing different amounts of stress as the moon goes round Jupiter. Now, the orbit of Europa around Jupiter is not perfectly circular, and that means sometimes it's closer to Jupiter where the gravity is stronger, and sometimes it's further away from Jupiter where the gravity is weaker.
Jupiter's a big thing. Its pull is pretty significant.
It's an immense gravitational field, and that means that when Europa is far away from the moon...
Like this observation.
Like this observation in December 2012, things are relaxed, you're able to emanate these plumes out of the South Pole. Now, the team also have observations from just a month earlier. At that point, Europa was much closer into Jupiter, so where the gravity field is stronger, if you like, and no plumes were observed at that point. So you have this situation extremely dynamically rich, where the plumes are only emanating their material into space when the stress is at its lowest point at the furthest distance away from Jupiter.
Now, this is a fabulously exciting discovery. It provides access to this water, the stuff we thought was locked up under the surface. And you have a mission, or you're part of a team working on a mission called JUICE, which is heading to Europa. So how does this change your plans?
It's being built by the European Space Agency to launch in 2022 or thereabouts. And at the moment, we're scheduled to have 2 flybys of Europa in 2031. We're going to be up close and personal with those plumes, able to look at the light as it's being filtered and scattered through them. We've even got instruments on board capable of detecting the sorts of materials that are emanating. Now, there's a huge caveat to that, I should say. What if this material isn't coming from the ocean? Maybe it's the action of something heating up in just the very top layers. Even then, it's still exciting because it's a way we can sample the surface materials from our spacecraft without landing on the surface.
So when does JUICE get there?
JUICE will get there in 2030, and it will fly by Europa twice in 2031.
Well, fabulous. We'll come back and tell us about it, and good luck with the mission.
Thank you very much.
Lee, thanks a lot.
Thank you.
So that's it for this month. But do remember to keep on sending your pictures in, especially if you manage to get a full rotation of Jupiter, and we'll put the best on our website.
When we come back next month, we'll be listening to the cosmos, studying sound waves to find out what they can tell us about the universe's hidden secrets.
And we'll also be looking at how to get wonderful images of the night sky with just